All right. Welcome back. We are again reviewing for our last exam, exam 4, and we're talking about the nutrition chapter. So, two words that we need to know is ascites and kwashiorkor. All right. Since we're here, let's start with this. This is an African word which means the disease of the abandoned child. This is because of a lack of protein in their diet. No protein, the liver cannot make albumin. No albumin, any water that comes out of your blood vessels can't be pulled back in by osmosis on the venous end of your capillary bed. Well, it doesn't stay in your tissues, it migrates to the largest open area in your body, the abdominal cavity. Okay? So their stomach is not this big, their abdominal cavity is full of water. All right? And if you're an adult with this situation, that's called ascites, okay? Which means a big bag of what? Water, all righty? And here is because, see how yellow her skin is? She probably has some kind of liver disease. And if her liver's disease, can it make albumin? No. Again, no albumin, the fluid accumulates in the abdominal cavity. Okay? All right, cool. What else you got?
Next up, positive versus negative nitrogen balance.
Okay, I can do that really quickly. Let's move over here. All of your proteins are made of what?
Amino
acids, right. And an amino acid is a carbon with 4 bonds. On this side, double bonded OOH. And on this side, a nitrogen with 2 H's. Okay? And since this is the only food that contains large amounts of nitrogen, we always talk about nitrogen balance, meaning how's your protein levels doing, all right? And remember, this is what we have to cut off to make urea, okay? Otherwise it becomes ammonia and kills us. And this part we can put into the Krebs cycle to make ATPs. So whenever we are using proteins for fuel, we always deal with proteins in balance. So what are we talking about when it comes to protein positive and negative balance? In positive balance, you are holding more proteins than you are using. That would be when you're growing, when you're healing from something. Does that make sense? Otherwise, if you're losing more proteins than you're putting in, that's negative balance. Okay? So that's basically all it is. What else you got?
All right. Hypoglycemic agent versus hyperglycemic agent.
Okay. I like those two words. Hyper versus hypo. And of course, glycemic. Okay, so emia, that's blood. Right. Hyper, too much, too little. All right. And the glyco, of course, means sugar. All right. Here's the key. What does the word, I can't spell, agent mean? What does this special word agent mean?
Something that causes it?
It's going to cause it. All right. So let's think this through. What hormone is going to cause my sugar in my blood to go up?
Glycogen? Or
no, glycogen is the stored glucose.
Glucagon. No, glucagon.
Yeah, right. So which agent is going to reduce the sugar in my blood?
Insulin.
Exactly. So where people get mixed up on a test is they think which hormone causes me to have high. Or what hormone is released when my blood is too high. No, it's not. It's what's going to make it get high. Not high to the point of being sick, but higher than it is right now. Okay? Does that make sense? All right. What else you got?
Right. Next up, what are chylomicrons?
Okay. When we are trying to absorb proteins, lipids, we are going to be picking up lipids somewhere in there. When you're picking up lipids, and I've been in the other chapter, how do I get lipids into my body?
The lymphatic ducts, or what is
Right.
it?
Well, it's the lacteals.
Lacteal
The
duct.
lacteals, like milk, because they thought that the white liquid was milk. Actually, it was just white fat. So it's not on here, but the lacteals, well, your lymph is basically water. Do water and oil mix? No. So the only way to carry the lipids is to hook them to a protein. And when you hook a protein with a lipid, for our lacteals, it's called a chylomicron, a small piece of chyle. Got it? Because CHYLE is the lipid. Okay?
Okay. All right. Where does cholesterol come from? Is the
Okay.
next one.
Now, cholesterol comes from, I think it's in here. Lipids. All right.
I know there was a slide about it. I remember.
Yeah. Okay. Now, we eat the fats. Who makes the cholesterol from the fats? Mr. Liver. Yeah. So he does that. Alrighty. Yeah. And there are two that we have to eat because we can't make them. We have to eat two essential fatty acids. And what's a fatty acid? Basically like a triglyceride. This is the glycerol part and 3 fatty acids. They're called fatty acids because they come from fat, and they're called acids because they can lose an H. Okay? All right. But yeah, so your liver makes your cholesterol. And unfortunately, some people genetically, like moi, makes too much cholesterol. Yes.
Can we, just to kind of jump,
Yeah.
can we talk about healthy LDLs and HDLs?
Yeah.
Because I know that.
Was that in here somewhere?
I believe so.
Okay.
Yeah, there it is.
Okay, there you go. All right. American. All right. Okay, I don't see any numbers here, so I'm not going to ask you any numbers. But your LDLs, the low densities, they carry a lot of cholesterol from your liver out to your body. It's to your muscles to give your muscles some fuel. Got it? So they're responsible for increasing your blood cholesterol levels. Your HDLs, on the other hand, their job is to pick up cholesterol from your blood and bring it back to the liver for processing. So what we want is a higher HDL content and a lower LDL content. Now, my liver just naturally makes more of this, over 100 and something, and very little of this. So I'm on Lipitor to make my liver flip that, okay, and make more of these, okay? So that's the most important thing, is that we want to have a low LDL, under 100, and we want a high HDLs as close to, if not over 100, okay?
Would very low density lipoproteins would be even worse than LDL?
I don't know. I'll be honest with you. It's not something my doctor even discusses with me.
Okay.
It's just a very low density lipoprotein, but what its purpose is, we never talk about that because these are the only two that we ever say, hey, good guy, H for healthy, L for lethal, bad guy.
Gotcha.
You know?
And just to make sure I'm thinking of it right, LDLs would be more like fat that you get from like meats or.
Well, no, LDLs are actually proteins made by the liver that carry fats.
Okay.
See, so it's the transport.
Gotcha.
So this one is a bus that brings the fat out to the body, and this is the one that brings the fat back from the body.
Okay. So you don't change those levels by what you eat. It's just what your liver
it's what your liver produces. Right.
Gotcha. Okay.
And that's the problem with me. Because my liver makes the wrong kind, too much of. My brother and sister, no. They make plenty of these and very little of these. So they got my mom's liver, I got my dad's liver. Okay?
Gotcha.
Genetically speaking. And that's why some people can eat, junk food all the time and no problem. Okay? And others, if I drive past the Bojangles, my cholesterol goes up.
What was it? I think you talked about it in the videos about how is it a certain fiber will increase your HDLs?
No,
what is it
but
that
I do know that there are something.
I remember you saying it comes from oatmeal.
Yes, it is oatmeal. It's a carbohydrate. Okay. Oatmeal is a carbohydrate, and as a carbohydrate, it's one of the few carbs that helps lower our cholesterol because it grabs the fat. Okay, and as opposed to not grabbing the fat. I don't know do I even have anything in here? I must have. Because if you heard me say it, I must have said it.
There it is. Yeah, right here.
Okay. Yeah. So oatmeal reduces blood cholesterol because this is soluble fiber, meaning even though it's fiber, it's the husks of something. It's the fiber part which you can't break down. It's helpful because it grabs the cholesterol. Okay. Psyllium fiber. This is your fiber that you put in your coffee or your tea or whatever, so you can go to the bathroom the next day. This is called insoluble. It won't float around in your blood. So that's why it goes into your intestines, but it's good for your large intestine because it draws water to itself, which then encourages you to poop better. Because one of the big things with a person who's got constipation is their poop is so dry, it doesn't want to move on out. Okay? So by having this, you're drawing water towards it.
So, like, soluble fiber doesn't change anything with your HDLs. It just naturally helps reduce your cholesterol levels. Okay.
Cool beans.
Cool beans. Next up, let's see. We might have mentioned this. What is cholesterol used for?
Okay. We can look at what cholesterol is used for. That's where it comes from. All right. Functions of lipids. Supplies energy to your muscles. Contains more chemical energy than anything else. Remember, it's 9 per lipid gram. Only 4 for carbs, 4 for proteins per gram. It can be used to synthesize and store fats. Excess can be converted into fat. Let's see, what else do we use it for? Lipid use. All right. We got the essentials. We got the combines. Okay. I knew I had the usage. Okay. Triglycerides, lipoproteins, fatty acids, cholesterol, phospholipids. In other words, building your cell membranes. Okay. And what else do we make from cholesterol?
Hormones.
All the hormones that are lipid-based. Okay, with the word ester in the name. So,
jump back to the next slide.
Back?
Yeah, right here.
Yes.
So, with cholesterol, it's used for making bile salts. Is that?
Yes, because bile is half fat and half base.
Okay. Yeah.
And the same thing with soap. Soap is half fat and half base. And detergents are half soap and half base, and shampoos. These are all things. Why? Because we want to dissolve the fat off of our hands, off the clothes, off the dishes. Well, you can't do that with a
acid.
No, you can't do that with a polar molecule like water.
Okay.
You need a non-polar molecule like more fat. Got it? And so the fat attaches. Here's we'll walk over here. Remember, we talked about emulsification last time? Remember emulsification? Where we had a piece of fat, and then we added to that pieces of bile. Well, bile is part fat and part base. Okay? Now, bases have pluses and minuses on them. Okay? And so these attach to the outside, but the only thing that's going to stick to the fat is more fat. Got it? And on the outside are your polar bases, which encourages water molecules to make a bubble around the fat, which we call a mycele. And it's these little bubbles of water-coated fat that then can be moved in your blood or moved down the drain when you're washing your dishes or your hands or your clothes. Does that make sense?
Yeah.
So in order to make bile, I need part fat. So that's one of the things your liver makes with the cholesterol that it's collecting from your blood. Okay, with the HDLs. It collects it and says, okay, let me use it to make hormones and to make bile. Okay? But that's why bile is not an enzyme. It doesn't snip your lipids apart. Lipase is an enzyme that snips your lipids apart.
Gotcha.
Okay? This just surrounds it in a bubble of water.
All right. Next up, all or none.
All or none. Okay. Let's go over here to our. Oops, not called. I need my proteins. Okay. Remember, your proteins have that amine group on the end. Got to keep that in mind. Okie dokie. All or none rule simply means that whether your protein is 20 amino acids long or 2,000 amino acids long, every amino acid that I need to hook together to make that protein has to be present in the cell, or we don't even start hooking it together. You know? You kind of say to yourself, okay, if you haven't got the first one, I can see why you wouldn't start. But can't you make all of it except for the last one? No. The way nature works, it's all or it's none. And that's why on the test, I'm going to ask you, the all or none rule pertains to what? Proteins, not lipids or carbs. Number 2, when I'm making a protein, is that transcription or translation?
When you're making the protein,
that would be the protein.
Translation.
That's right. It's the second step, because the first step is DNA to RNA. It's the second step that's RNA message to the actual hook together of the protein. Okay? Make sense? All right.
Next up.
Hold on. Can you look over there real quick and see if we... No, on your paper.
Okay, yeah.
Can you see if we have something about essential proteins and essential amino acids?
I just see complete and incomplete.
Okay, that's it. That's close. That's the same idea. Okay? All right. Proteins.
Yep.
Proteins contain all 20 amino acids. Got it?
Mm-hmm.
However, we need the meat because no plants contain all 20. Alrighty? That's why 12 we can make, but there are 8 that we cannot make. We have to eat them. Alright? Now, are there any plant sources with all 20 amino acids? The answer is no. The all 20 amino acids are in the meats and the poultry and stuff like that. Anything that comes from an animal contains all 20. Alrighty? So what's a vegetarian going to do? The complete. All 20 amino acids. Everything else is called incomplete because it doesn't contain all 20. Alright? It doesn't contain the 8 essentials that we need. So, this is why I like this slide very much. If we're going to be a vegetarian, we have to have a grain and a bean together. And here's the reason why. You don't have to memorize what these things are. Just take a look. See, corn contains these 1, 2, 3, 4, 5, 6, but not 8. And beans contain these 1, 2, 3, 4, 5, 6, but not the total 8. So only together do you get your essential amino acids, which are the ones that we're waiting for the all or none rule. Got it? So eating meat, eating fish, eating eggs, you got them all. But if you're going to be strict vegetarian, then you don't have them all, and you have to eat your food in combination. Okay? And here's the cool thing. Societies all around the world figured this out without even knowing what nutrition is. Because in the Southwest, in Mexico and whatnot, corn, tortillas, and beans. Don't need the meat. You got your amino acids that you need. If in Asia, what do we have? We have soybeans and rice, right? And even in America, we came up with a peanut butter sandwich because there's the grain, is your bread, and the peanuts are a legume. Okay, so we can live off of just that. It'd be very boring, but we could do that. Make sense? But that's why we have to have a combination of vegetable food. We don't need a combination of meat food. Okay? And the 20 amino acids, think about going to a library. Is every book in the library the same? No. But they're all written, with the same 26 letters of the alphabet. Every protein, whether you are a crayfish, or a person, or an octopus, they're all made with the same 20 amino acids, just in different groups, different order. Okay.
All right. Let's see. I think the next one, how are nutrients absorbed into the blood? We put that one down for next week.
Yeah. I thought there was a picture for it, but I just looked through it. I didn't see it. Okay. However, it's very simple. How do we put lipids into our blood? Through the lymphatic system. Got it? Everybody else straight into the blood of your villi. Okay? So carbs, proteins, nucleic acids straight into the blood. Most of your lipids, now they're shorter fatty acids and whatnot, can go into the blood, but most of your big lipids have to be turned into chylomicrons, hook them together to a protein, and sucked in through the lymphatic system. But that's okay. They're going to get dumped into your vena and your subclavian veins, so it'll end up in the blood eventually. Okay.
Cool. All right. Which vitamins synthesized in colon is what the
B and K. The E. coli that live in your large intestine, we feed them the insoluble fiber. Got it? That's why we fart a lot when we're eating a lot of beans. Okay? Because the coating on the bean is something that our body can't break down. But the bacteria can break it down. They like that stuff. Okay? And as they're happily chomping down, they're saying, chomp, 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 thank you, and they're putting out flatus, from which we get the word flatulence. All righty? That's the gases that we make, that we, because the bacteria are making that, the E. coli that we have in there. But if that's all the E. coli did, we probably wouldn't like them a lot. I mean, who's saying, I want to fart more today? So they actually poop out vitamin K and vitamin B for us. So that's why it's a symbiotic relationship. We want them in our gut. In fact, if they're not in our gut, we have difficulties. Got it? So if you're somebody who's taking antibiotics all the time, you could very easily upset your gut bacteria, cause constipation and gas and bloating and this and that. Okay?
Is that like what probiotics are?
Yeah. Probiotics and prebiotics, I can't keep them straight. But one is to promote health of your biome, and others is to add to your biome. Got it? So one of them actually is live bacteria that they want to put into your intestines.
All right. Next up, complex versus refined carbohydrates.
Okay. Go to our carbs. All right. Refined and complex. Basically, if your carbs come in natural form, as fruits and vegetables and whole wheat bread, it's complex because you not only have empty calories, but you've also got some other nutrients in there. You've got some other minerals and vitamins and stuff in there. Got it? You eat a banana or an apple or whatever, you're going to get vitamin C and vitamin A. You're going to get these kind of things. Refined or simple is pure junk. Got it? That's a Coke. That's a candy bar. That's a a gummy bear, it's pretty much only empty calories. Okay? Now, unfortunately, it's also very cheap, and people buy a lot of it, figuring, I'm hungry, let me eat a couple of candy bars, but you're not getting a lot of nutrition out of it. Okay? Because these are refined. What does that mean? All the nutrients have been cooked out of it and baked out of it and taken out of it. It's like pure cane sugar or just pure high fructose corn syrup. There's nothing in there but calories. There's no other nutritional value to it. Okay? And that's why it's called simple or it's called refined, because that's what we did. We processed it so much there's nothing left other than sugar.
Gotcha. All right. Vitamin/mineral deficit and the corresponding disease.
Okay.
I know we got a bunch of these.
There's a good bunch of that.
Yeah.
So just make sure, I would make a flashcard of it, for each one. Did I miss it? Oh, here we are. Vitamins. There we go. Okay. Fat-soluble ones, K, A, D, and E. K. Okay. Now most books call it A, D, E, K, but I can remember K easier. Okay. So, what does that mean? They're made of lipids, and we need to eat lipids in order for them to be brought into our bodies. Got it? You take this with no fat intake, you poop it right out because it never had a chance to get into your blood. Okay? So that's why fat-soluble vitamins, you need some fat in your diet. Number two, because they are fat-soluble, they stay in your liver, which collects a lot of fat, and it stays in your fatty tissue. So these are the only vitamins that could lead to a disease called hypervitaminosis. Too much D or E or K. What will happen with too much of these? Liver damage. Is that a good idea? No. So that's why when you buy your multivitamins, you'll notice that these guys are in very small amounts, micrograms worth. Okay? Now, on the other hand, the water-soluble ones, the B vitamins and the C vitamins, you can't overdose on them because if you have too much and your cells don't use it, we pee it out. Now, of course, as my doctor would say, you can eat as many of these as you want to, but now all you're doing is wasting your money because you're making expensive pee. Okay? Well, see, that's why. They're water-soluble. Okay? They can't overdose, and you excrete it out. All right? And, of course, the B vitamins, there are multiples of them, and they're all used for energy. Okay? And so we call them B complex, because it's more than one B vitamin. All right? Okay, so let's take a look at each one. Vitamin A is the vitamin, and the dark bold print is the deficit. No vitamin A, night blindness. You see this when you're driving down the road instead of that. Is that a good idea to be driving down the road at night? No, you'd be in pretty bad shape. You can't see anything, okay? Daytime, fine, but not at night, okay? Night blindness. Please take a look also. Gee, I wonder what part of the eye this deals with. The retina, yeah. And it's OL, so it's a fat soluble, like cholesterol, okay? All right, D. You can see OL again, deals with calcium, all righty? What's the deficit? In kids, it's called rickets, where your legs are bowed because you stood up before you had enough calcium in your bones to make them strong enough. And your legs actually bent when you tried to stand up. Or osteomalacia, bad bones. In an adult, you would have easy breaks, or you would have things that are not functioning properly, not growing properly. All right. Vitamin E, tocopherol, again, an OL, and you can see this. And one of the main things that it's used for, it's an antioxidant. That's why it's in a lot of face stuff. So the antioxidants like hypercharged oxygen molecules and other things that come from car exhaust and whatnot, age your skin. Well, the idea is let's not age your skin. Let's stop those antioxidants. Stop the oxidizers with an antioxidant. Sorry, that's why it's in here. Vitamin E oil. Okay, what's the problem? Vitamin E, if I don't have enough of it, I'm going to get hemolysis. My red blood cells will pop. Is that a good thing? No, because now you're going to get anemia. Okay? All right. Vitamin K comes from the word coagulation in German. So what does it do? It helps you clot your blood faster. So what's the problem if I don't have enough? Easy bruising and bleeding. Okay? Which makes sense. Now let's go to vitamin C and the vitamin Bs. Vitamin C comes from citrus fruit. That was first discovered. And they called it vitamin because they thought it was a mineral for life. That's when the name vitamin came up too. And if I don't have enough vitamin C, I get scurvy. Like the pirates always say, I use scurvy knave. And what is scurvy? You lose hair, you lose your gums, you lose your teeth, your skin looks horrible. It's called scurvy because that means mange in European languages. Okay? But real mange that a dog or a cat has is not a lack of vitamin C, it's a little bug that lives in your skin and eats the base of the hair, making the hair fall out and the skin look horrible. Okay? It's called a Demodex mite. So that's not the same thing. But that's why you would need this, because it's all about helping to synthesize collagen, this tough stuff that makes up your gums and holds your teeth and your hair and stuff like that. Make sense? Okay. All right. Vitamin B1, thiamine, or thiamine, see, you can tell that's going to be protein. The big disease is called beriberi. Okay? Just match it up. Beriberi comes from the African word I cannot. And that's because somebody said, hey man, get up here and help me carry this stuff. Beriberi. They were on the ground, they couldn't get up. They didn't have any energy. Okay? See, it's very important for your heart, muscles, nervous system to work, because it's all about helping you break down carbohydrates to make the energy ATP molecule. All right, riboflavin, number B2, the second B. What does it make? Dermatitis, bad skin. Chelosis, cracking of your lips. Glossitis, inflammation of your tongue. All righty? Now, what am I going to ask you on the test? This right here. See the word riboflavin? It's the F of FAD that we use to pick up electrons and hydrogens in the Krebs cycle. That's all B vitamins do. They help work the Krebs cycle correctly and the ETS correctly, okay? Because they're picking up the hydrogens and the electrons and delivering them to that last step. B3, niacin, okay? G, the N of niacin is the N of NAD, the other molecule, okay? That picks up. Remember, NAD picks up the H and becomes NADH. So, if I say on my test, what's the function of NAD? It's to pick up H's. If I say, what's the function of NADH? It's to drop off the H. This can't drop off an H, it hasn't got it yet. Okay? All right. And the disease is called pellagra. All right? Scaly skin, delusions, all sorts of other problems. Now, here's the good news, folks. You're not going to see a lot of pellagra. You're not going to see a lot of beriberi in this country. Why? Because the main source of vitamin B is fresh fruits and vegetables, which of course we're not eating enough of. So what did the FDA say? Hey, people who make bread, stick it in the bread. Got it? Because another good source of NAD and FAD, not FAD, but B vitamins is wheat and flour and stuff like that. But again, what do we do with those carbohydrates down at the old processing plant?
Big amount.
We cook them to death, we break all the stuff up, we basically turn it into nothing but pure starch with no value. That's why the FDA said, we don't want people like this happening. Because they were buying Wonder Bread or whatever, they were buying bread and eating it instead of making their own bread from the wheat they grew in the field behind their house. And people started getting pellagra. This picture here is the last person to die of pellagra in the United States. Because it was after this time that we said, no, we are going to nip this in the bud and put those vitamins directly into all the bread that we make. By law, FDA says you make a bread, you're sticking vitamins in it. Okay. All right. Then there's B12. Again, see, it's a protein, IN. And when I don't have enough B12, I get pernicious anemia. This is now the third time we've seen it, because pernicious anemia is one of the things that causes problems with your red blood cells. And so we saw it in the blood chapter. We have something called intrinsic factor inside the lining of your stomach, which makes us be able to absorb B12. Okay? So we saw this in the digestive system. So I need to have B12 in my diet, but I have to have intrinsic factor to absorb it. Lacking either one of those two, I get pernicious anemia, which has all sorts of problems. Why? Because you can't build your red blood cells correctly. Okay? All right, folic acid, known as folacin, was very important for moms as the baby is growing. Take your folic acid, because without it, your baby might get spina bifida. Okay? Which is, instead of the vertebra closing and your spine staying in the middle, your spinal cord, it stays open, your spinal cord bulges out. Which, of course, if anything happens to this, you're going to be paralyzed from there down.
Can they fix that if that happens?
Yeah. Back in the old days, you had to wait for the baby was old enough for them to be able to do the operation that could survive. Now they can do microsurgery. In fact, I've even read somewhere they can do it in utero. They see it starting to happen, they can go in there and just pull those two vertebrae together or something.
That's crazy.
It's amazing. Which is why it's important to have regular checkups when you're a new mom, because you want to make sure that the doctor can do ultrasound and see if the baby looks good from head to toe. And if it happens to the rest of you, you get megaloblastic anemia, where your red blood cells that are being this side are extra large, and again, not functional. All right, minerals. Same concept. We have major minerals. We have minor minerals. Okay? That you don't have to have a whole lot of. And what are the problems? No calcium, rickets in kids, osteoporosis in grandma. Sodium. Do we ever have a deficit in this country? No. So for us, what's the excess? High blood pressure and, edema. All right, potassium. Excess potassium in your blood, you're going to have bradycardia. Your heart won't be able to get to the next beat, which is why, what's in the lethal injection? High potassium. Potassium chloride, all right? And if you don't have enough, you get tachycardia, which means it's to quickly get the next beat, Okay? All righty. Minerals. Well, if I have too much of magnesium, I get diarrhea, like Kenny over here. Or not enough, I get arrhythmias. Because again, magnesium, chlorine, sodium, potassium, calcium, all of these things have to be in range, or you're going to get arrhythmias. Too fast, too slow, skip a beat, whatever it is. Alrighty? In this case, magnesium plays a role in working your sodium-potassium pump correctly. Okay?
One quick thing on magnesium.
Yeah. Mm-hmm.
Isn't magnesium in like a lot of it's like an Epsom salt.
Epsom salt made of that. Yeah.
Which people sometimes take as a laxative,
right,
and stuff like that.
And that's why if you have too much, you're really going to be shooting the shit. Okay. All right. So, but yeah, you're 100% right. What's the rest of the Epsom salts used for? Soak in the tub.
Yeah.
It helps to relax your muscles so it doesn't hurt, it doesn't cramp as much. Okay, iodine. Iodine is very important for making your thyroid work correctly. That's why the two thyroid hormones are called T3 and T4. T3 means I got 3 iodines. T4 means I got 4 iodines. Okay? All right. What is the problem? Usually we don't have to worry about too much iodine in the diet, okay? Unless you're over there eating iodine pills or something, all righty? We pick up what we need from fresh fruits and vegetables. We have a bigger problem with not having enough, all righty? If I don't have enough, then I get this, hypothyroidism. That's a before and after picture. With hypothyroidism, your thyroid's not working, which makes you more depressed, and there's no energy, because remember, your thyroid is all for metabolism, get up and go. Well, the doctor who specialized in this in London during the 1800s, he took pictures of his patients before and after. Once he diagnosed that you were missing function in your thyroid, he very wisely said, okay, if your thyroid's not working, you need to eat more thyroids. Well, what are you going to do? Cannibalize your neighbor? No. He said, go to the butcher shop. There were no grocery stores. You go to the butcher shop and ask the butcher, can I have as many thyroids as you have? Because he's back there slaughtering the cow. So yeah, nobody eats that. So here, you can have it. He said, go home, cook it up and eat it. Well, when the people were eating it, guess what they were eating? A large supply of iodine. And they got better. Okay? All right, now what about this lady? She lives in a place where there's no iodine in the ground. So no matter what she eats that she's grown in her village, there's no iodine. Well, that means her thyroid is starving for it. And one of the things your cells do, or your organs do, when they're looking for something, they grow bigger. Why? Because they figure, if I'm bigger, I'll have more capillaries. If I have more capillaries, maybe I can suck up more iodine. Well, there's nothing in your diet. It's only going to get bigger and bigger and bigger. Okay? And that's why a lot of these mercy ships come along to give her a quick operation.
Did they just cut out part of the
thing? Yeah, they cut the whole thing out, yeah. Or at least the part that's overgrown, yeah. And we just don't see a lot of that in this country, because where do we get a lot of our iodine? From fruits and vegetables grown where? California, Mexico, the ground is full of iodine there, okay? We didn't have a lot of goiters here in South Carolina. I didn't know this, so I watched a commercial, but the TV station in Columbia is called WIS, TV 10. Guess what WIS stands for? Wonderful Iodine State. I didn't know that. So apparently, if we ate what we grew in our backyard, we got plenty of iodine. Okay? But there are areas in the Midwest and where there isn't enough iodine. Okay? All right. And of course, in some parts of the world, there's no iodine at all. In this island or on this, place in this part of the continent or whatnot. And you get a lot of this. All right, called goiter. Now, iron, obviously, iron poor blood if you don't eat enough iron. See? Anemia. Gotta take your Geritol. All right, phosphorus, because what are your bones made out? Calcium phosphate. So I got the calcium, but I'm missing my phosphate. I still gotta get rickets. And what they say, I got this off the internet, this lateral thrust of the legs, pushing out as opposed to knock knees pushing in, is your classic hypophosphatemic rickets. That's your classic. Okay?
Low phosphate in the blood.
Low fat phosphate, yeah. Okay. Cool. So to help out, we have supplements. But be careful. Can't take too much. Some vitamins interact with your medicines. Your doctor will be able to tell you that. And other times you don't want to be overdosing on the fat soluble.
All right. Let's see. We already talked about complete and incomplete proteins.
Mm-hmm.
We already talked about the sources for NAD plus and FAD.
Right. Niacin and riboflavin. Yeah.
The next one was, what role do they play in cellular respiration?
There you go.
This next question I know is next week. It's talking about the reproductive system.
Yeah.
So the last one is, what is glucose sparing?
Sparing. Not
Sorry.
sparring, yeah. Sparring is fighting. Again, my glucose is fighting with your glucose. No. Sparing. It basically means that when you're starving, any glucose that your liver can make for you with gluconeogenesis is going to be saved for your brain and not used by your muscles. Your muscles say, just give me the fat, I'll turn that into Krebs cycle material to make ATP. Any little glucose that we can make, like I said, when you're starving, will be spared to keep your brain and your nervous system alive. Because your brain and nerves cannot make ATP from anything other than glucose. So we have to spare it for that. And that's why some people who pass out from starvation can't be brought around with just a little half a teaspoon of sugar. Just that sugar going into your blood will go straight to your brain and wake your brain up. Yeah, it's amazing. Is that all of it?
That's it.
My, can you make sure the next ones are all just reproductive? Not that I made another boo-boo.
Yeah.
Okay.
I think we're good.
All righty. See you later. Thank you, sir.